Okay, so we're going to be doing lead code 451, sort characters by frequency. So you're given a string S and you're supposed to sort it in decreasing order based on the frequency of the characters. The frequency of a character is the number of times it appears in the string. Return the sorted string. If there are multiple answers, return any of them. So this tree becomes EERT, right? So it's sorted based off the frequency, which is E is the most is the character that appears the most, so it appears first, and then R, and then T, right? So what we're going to use a max heap and a dictionary for this, right? So the first thing is we create a dictionary counter, right? So let's call it a frequency table, right? We create a frequency table using a dictionary, which is actually a hash table. So we'll call it a frequency table is equal to use the counter function. We could have done it ourselves, but I mean, you can just use this. So is equal to counter S, right? So now we have a frequency. We have a dictionary with the frequency of each item. So here it would be T with 1, R with 1, and E with 2, right? So now that we have this, we create a list of tuples with the frequency set to negatives, right? So we'll call this store is equal to that, and then we get the frequency and the item, the frequency and the character from the frequency table or dictionary, right? So how do we do this? We say for, we'll say for, where will the frequency be? For frequency val in, we say for frequency val in frequency table dot items. So this returns the val to be key val, so it will be val frequency, right? So what this does is it goes in this table and it gets each key value pair. So this is the key, which is our value, and the value is the frequency, right? So we grab all those and then we append them to the store as a tuple, right? So store.append, we're going to put val first. Okay, store.append, we're going to put val first, but as a negative because we want to get a max heap, and then frequency second, right? So now we have a tuple containing our frequency and the val, which is a character, right? So hold on, did you say val frequency? Okay, we're gonna switch these up. I made a mistake. So frequency should actually be negative, and this we should call it character, not to get confused. So frequency character, right? So now we have a tuple containing our frequency and character. We have a list of tuples, each containing our frequency and character. Sorry about that. So we convert it into a max heap. It's a max heap because we set our first index, which is this one, to negative, i.e. frequency, right? So how do we do this? We say heap q dot heapify store, right? So now we have our result, which will be result is equal to that, And then while k is greater than 0, what are we going to do? We're going to say k minus equals 1. What we're doing here is we're going to iterate through the store, popping it off and adding to res, right? So we come here, we say we'll say frequency again is equal to heapify dot heap pop store. But a store we want to get, okay, we'll get the tuple out first, right? So when we pop it off, we get the frequency and the car, right? So we get out the tuple, and then we adjust the frequency back to a positive, right? So we say frequency times equals -1, right? And then we append the car to the result frequency times. So we say for underscore in range frequency, what do we do? Result dot append car. So when we come back here, we return this dot join res. So this is the solution. While k is greater than 0. Oh, sorry. Made a mistake here. There is no local variable. Okay, so we have our res. So this is this is not k. This is while store, right? Because we don't have any k. While store, i.e., while our heap is not empty, right? This is what we do. Sorry about that. Heap pop, heapify, heap q. Sorry, this is supposed to be heap q dot heap pop. And voila, it works. Right? So that's the benefit of using a heap. Okay, so this is a solution. It takes O of n. It takes O of n time and O of n space. It takes O of n log k time. And then it takes O of n space because we're creating these stores. Right? So this is a solution. Thank you and bye.